My viewers and learners, we shall proceed to our lessons for today, and we shall be treating the topic matrices. The singular form of it is matrice, while the plural is matrices. And what are matrices, or what is matrice? It is the arrangement of numbers in rows and columns to form a rectangular array. These arrays, or the array of numbers, are being enclosed in a bracket. For instance, may have entries such as 2, 1, 3, 4, 5, and 6. This is a picture of what matrice, or arrangement of numbers in rows and columns, look like. Another thing we should know about matrice is that if we have an m row and n column, we describe this as m by n. The order is m by n matrix. Having said that, we'll move over to types of matrix. We have the row matrix. Row matrix. A matrix is said to be a row matrix, or is called a row matrix when it contains only one row. For a row matrix, 2, 4, 6, 8, this is a row matrix. Column matrix contains only one column. Always enclose this. A column matrix can have many number of rows, as you can see here. But one key thing you should know about column matrix is that it is a matrix that contains only one column. Another type of matrix you should know is square matrix. Square matrix, a matrix is said to be a square matrix if both the row and the columns are equal. For example, 1, 2, 3, and 4 is a square matrix because we have equal number of rows and columns. Here we have 2 rows here and 2 columns. And if you want to describe this type of matrix further, this is also known as square matrix of 2 by 2. It is 2 by 2 because we have 2 rows and 2 columns. Remember, in matrix, in describing a matrix, we state the row first. What if you have a matrix of this order? Let's say you have 3, 1, 4, 6, 7, and 8, 9, 6, and 5. What order of matrix is this? This is, you have how many rows here? 1, 2, 3. This is order 3 by, how many columns? 1, 2, 3 as well. 3 by 3. You can see what a square matrix is all about. Then another kind of or type of matrix is unit matrix. A unit matrix is a matrix that has the diagonal as 1, or the matrix that has all the elements as 1 at the diagonal. What do we mean by diagonal? If you have arrays of this order 1, 2, 3, 6, 7, and 8, 1, 4, and 5, the diagonal elements or numbers are 1, 7, and 8 here. Diagonal matrix. Diagonal matrix. If you are given this kind of matrix, let's say A equal to 1, 4, 7, 3, 5, 8, 9, 3, and 2. The diagonal elements here are 1. Picking out the diagonal, A11 is equal to 1. A21 is 5. These are the diagonal elements. Then A33 is what? 2. Now coming back to what diagonal matrix is, it is simply a matrix that has all the diagonal of non-zero, while other numbers in the array are zeros. For example, if you have 2, 0, 0, then 0, 4, 0, then 0, 0, 6. This is a typical example of a diagonal matrix. It is only the elements or the entries at the diagonal that are non-zero. Other ones outside the diagonal are zeros. Then what about zero or null matrix? Zero or null matrix. This is a matrix that contains all the entries as what? Zero. Everything there is zero. All the elements, they are all what? Zero. This is just to refresh your memory of what you may have learned some time ago. Now let's quickly go to algebra of matrices. Algebra of matrices. The first addition of matrices. We can only add two matrices if and only if the corresponding elements are of the same order. How do we mean? Let's take, for instance, you have 3, 9, 7, and 2 as matrix A. Then matrix B is 2, 6, 4, and 3. You can see that they are of the same order. This matrix A, the order here is 2 by 2. How? We have 2 rows and 2 columns. Remember, in matrix, we state the rows first. And if you come to matrix B, it's equally 2 by 2 order of matrix because we have 2 rows and 2 columns. Now, how do we add? We add the corresponding element. Let me clean up the lines so that you can see the entries clearly. We have 3, 9, 7, 2 here. Then clean up this as well so that you can as well see it clearly. We have 2, 6, 4, 3. Now, adding the corresponding elements, A plus B equal to 3 plus, you first do it this way, 3 plus 2, then you column by column. That is how we add in matrix addition. Column by column. This is column 1. You use it to add to the corresponding column at the other matrix. Now 3 plus 2, you have that. Then the next one is 7 plus 4. You are done with this. Now the next entries to be added is 9 plus 6. 9 plus 6. You equally have here 2 plus 3. Remember to enclose the entries in a bracket. Continuing this other side, 3 plus 2 is what? We have 5. 7 plus 4 is 11. and 9 plus 6 is 15. Y2 plus 3 is still 5. Therefore, A plus B equal to 5, 15, 11, and what? 5. The sign of equality in matrix should appear at the second row. I hope that is clear. It is very simple and interesting. We can as well add another set of matrices, giving A as 7 minus 5, 2, and 4, and matrix B equal to 3, 1, 6, and 2. Therefore, A plus B, just as we did in the first example, 7 plus 3 is what? 10. 2 plus 6 is 8. And we have here minus 5 plus 1 is minus 4. 4 plus 2 is 6. That is that for matrix addition. Having done that of addition, let's quickly move over to matrix subtraction. The same thing is applicable in matrix subtraction. Two matrices can only be subtracted if they are of the same order. We subtract the corresponding elements. Giving A to be 7, 9, 8, and 1. This is first matrix. And B equal to 3, 2, 4, and 5. Now, A minus B is simply, just as we did in matrix addition, 7 minus 3, 8 minus 4, 9 minus 2, 1 minus 5. Giving us as what? 7 minus 3 is 4. 8 minus 4 is also 4. 9 minus 2 is 7. And 1 minus 5 is minus 4. Therefore, A minus B equal to this. It is very interesting and very simple. Let's solve one example again before we move to multiplication of matrices. Like I told you in my introduction, in this channel, it is a channel where mathematics is being made easy. You learn mathematics with interest and you rejoice that you are learning it, not learning and frowning or complaining. There's nothing wrong with mathematics. Let's solve another example. Given A to be 6, 4, 3, and 2, and B to be 1, 4, 7, and 8, find or subtract B from A. Now, A minus B is simply, just as we did before, 6 minus 1. Then you have 3 minus 7. The next one is 4 minus 4. The next one is 2 minus 8. 2 minus 8. 6 minus 1 is 5. 4 minus 4 is 0. 3 minus 7 is minus 4. 2 minus 8 minus 6. Therefore, A minus B equal to what you are seeing here. Now let's quickly look at matrix multiplication. The case of matrix multiplication is totally different from that of addition and subtraction. Two matrices or two or more matrices can only be multiplied if the number of columns in the first matrix is equal to the number of rows in the next matrix. Taking for instance, if we say that in matrix multiplication, the number of columns in the first matrix must be equal or the same with the number of rows in this next matrix. If you check in matrix A, we have 1, 2, 3 columns. And in matrix B, we have 1, 2, 3 rows. So it has met the condition for matrix multiplication. Now, how do we multiply? We multiply row by column. We pick the first row, we multiply this first column, still use that same first row to multiply the next column. We do that, thereafter we add. Let's go. Now, the solution to get the multiplication done, 2 times 4 plus 3 times 3 plus 4 times 2. We are done with this row, multiplying this column. You now move again, using that same row to multiply the next column. 2 times 1 plus 3 times 1 plus 4 times 2. You are done with that, you move over to the next row. 1 times 4 plus 5 times 3 plus 1 times 2. Still use the same row to multiply the next column. 1 times 1 plus 5 times 1 plus 1 times 2. Make sure you enclose in a bracket. 2 times 4 is 8, plus 3 times 3 is 9, plus 4 times 2 is 8. 8 plus 9, 17, plus 8, you have 25. The next one, 1 times 4 is 4, 5 times 3 is 15, plus 1 times 2 is 2, 4 plus 15 is 19, plus 2, 21. 19 plus 2 is 21. The next one, 2 times 2 is 2, times or plus 3 times 1, which is 3, giving us 5. 4 times 2 is 8. 5 plus 8 is 13. 1 times 1 is 1. 5 times 1 is 5. And 1 times 2 is 2. This is 1 plus 5, giving us 6 plus 2, 8. This is how matrix multiplication is done. Therefore, AB equal to 25, 13, 21, and 8. It is very interesting. I believe if I drop one for you to try at your leisure, you should be able to do that. It's very interesting. At your leisure, try this. Try this. 2, 6, A equal to 2, 6, 7, 3, 5, 4 as matrix A, while B is 6, 2, 5, 3, and 2, 0. At your leisure, you can play with that. There is a question here. Verify the associative law A, bracket open, BC, bracket close, equal to AB times C for the following matrices. We have matrix A, B, and C. In our next class, we shall verify the associative law. Remember, when you are given something like this to verify, what you need to do, first, you deal with what is in the bracket, use B to multiply C. We have done matrix multiplication. I believe you should be able to do it. And remember, after you're solving, the answer at the left-hand side must be equal with the answer at the right-hand side, because matrix multiplication has the property that it is associative. One of the properties of matrix multiplication is that it is associative. That is, this equal to this. In our next class, we'll verify the given matrices. Bye.